Right. So this is the place we have start today, right? So we had this heading, and we are copying this particular highlighted part to have the description under the color in a pixel and the number of bits, right? So we are going to continue from this. So next is representing it's just a representation for you to how this thing is happening. So we talked about it, and we are not going to write these things down, right? Just remember the remember this equation, right? So in most of the cases, you need this particular equation to figure out how many colors that you can use, right? And continuing downwards, we are here to talk about the resolution. Now, I think you have heard the word resolution, right? So some may have an idea about what is the resolution is, right? So that pixels are used to measure the physical dimension of a digital graphic, as it says, right? So how now resolution means like how many pixels are being used horizontally and vertically, right, as a matrix to represent a particular image, right? So as they says, like this particular illustration, this particular small picture, it's a 250 width pixel and 175 pixel height. 250 of pixels are there as per width and 175 pixels are there as per height, right? So it is kind of a matrix which is made out of those pixels, right? So let me illustrate it to you first. Right, and that means if you divide this picture into pixel by pixel, right? If we think about this is a one particular small pixel that we have, right? Actually, it should be only within the picture in there. Then මේ pixels වලින් මෙයාව හැදිලා තියෙන්නේ. So if we imagine the pixels, this little box is representing a pixel, right? So there are 250 pixels horizontally, 250. Likewise, 175 pixels vertically, right? So like all together, there will be like 43,750 pixels, which to cover this or to create this particular picture. So that is what we call the resolution, right? So when you are referring into a particular picture, it says how many pixels are being used horizontally and how many pixels are being used vertically to create that particular picture, right? And now you can understand if your picture is low in resolution adu enam, when you enlarge in the picture, that particular pixel will enlarge in big manner, right? ඒක හරියට අපි Word document එකක sales ගාන අඩු table එකකුයි sales ගාන වැඩි table එකකුයි යන්දව. Right? Now, if I insert a table with something like this, and if I insert a table, something like this, right? If I fix the size of the table columns, right? Right, මම මේවා එක අඟලක් උස එක අඟලක් පළල squares හදුවා කියලා හිතන්නකො. So these things I'm going to do the same. Right, now what's happening is, as you can see, now if this is a now pixel එකක size එක ඒ size එකම තමයි, right? එතකොට දැන් මම මේ picture එක ලොකු කරොත් මගේ කොටු ටික ලොකු වෙන්නේ ලොකු වෙන තරමට වඩා මෙයාව ලොකු කරන්න ගියොත්, if I maximize this into the same size, you can see like this particular pixel is enlarged in a big manner comparing to this particular pixel, right? Then I make a color එකක් දුන්නොත් right, right now this picture's resolution is like 4 pixels, like 2 by 2, right? Yeah, Minul, we are talking about the pixels, the resolutions actually, right? And at page number 84, right? So this is a picture which has 4 pixels, a wage, right? This looks alike a picture which contains, if I take this to the next page, right? So this looks alike a picture which has 5 pixels per to the width and 4 pixels to the height. So there are 20 pixels inside it. Now when I'm enlarging these two were same in size earlier. So මෙයාව enlarge කරනකොට අපේ paper එකේ size එකට, this one is enlarged more comparing to this particular picture. Pixel enlargement එක මම කියන්නේ. Pixel එක ඇදෙන ප්‍රමාණය වැඩි වම් අත පැත්තේ picture එක මෙයාගේ අඩු. So this matters on the quality. Right, now in your book they have given a very nice example earlier, right, about this. Now here the number of pixels are less, right? So when it is being enlarged, we can see a blur picture on the screen, right? But pixels ගන්න වැඩි, resolution එක වැඩි වෙනවා කියලා කියන්නේ මේ image එකේ size එකත් ලොකු වෙනවා. So when we enlarge that kind of a picture up to this size, it won't be that blur like this particular picture, right? So resolution matters to indicate or to illustrate the quality of the picture, right? So if you are taking a high resolution picture, means that picture contains lots of pixels. So containing lots of pixels means the quality of the picture is good, right? So low resolution will give you low quality pictures. High resolutions will give you high quality pictures. People, is that clear?
Yes, sir.
Right, great. That is why when we are saying, when we are doing the graphic editing, we are always asked to download the larger pictures, or like larger resolution pictures, right? So then our output will be something very quality comparing to a low quality one, right? But again, when you are creating icon kind of things, small pictures, we really don't need that much of resolutions into it because it represents a very small picture. So we can decrease the resolution as per our need. Right, then එළියේ ඔගොල්ලෝ පාර එනකොට දැකලා තියෙනවානේ the big hoardings that they are displaying. So for those kind of things, they need a very pictures with very high resolutions. Right? Otherwise, that big hoarding will be a blur image, right? But if you are representing a particular icon, you really don't need that much of resolution. It will be much easier for you to have a low resolution picture for the icon or the bullet kind of things. And you have to remember, when your resolution is high, pixels will be high. Pixels will be high means the number of bits contained in that image will be high in number as well. That means the capacity is big as well. Right? The resolution එක වැඩි වෙනවා කියලා කියන්නේ pixels ගාන වැඩි වෙනවා. Pixels ගාන වැඩි වෙනවා කියලා කියන්නේ එක pixel එකක් ඇතුළේනේ bits තියෙන්නේ. So if the number of pixels are being increased, that means number of bits will be increased eventually. Right? So it will create a high quality image as well as high capacity image. Right? Now, if you take a photo from a DSLR camera, right, which is a professional camera, your picture may have a capacity of like 10 to 15 megabytes, right? ඒක ගොඩාක් enlarge කරන්න පුළුවන්, right? But if you really want to have something for your, like say, for some project or for some visiting card, right, or for some invitation, you really don't need that much of resolution. එකෙන් වෙන්නේ output එක බර වැඩි කරන එක විතරයි, right? Okay, let's write about the resolution. So have the subheading and yeah. Yeah, let's say it like this. Yeah, copy this. Right, and yeah, write this as well. And I'll draw you some diagram after this, so you can draw it to indicate what is the resolution means. All right, one is done. How about others? All right, great. Right. Is there anyone still writing this? I'm going to move forward. Please indicate if there is anyone. Right. Okay, so yes, you can draw this particular diagram under your note to specify the resolution. Yeah, let's do it like this. අපි මේ ටේබල් එකේම තියෙන එක සෙටල් කරගමු. මම පොඩි කරන්න ඉන්න. Right. So it's better you draw these two metrics and indicate this picture as low resolution picture. So this is 2 pixels and this as 2 pixels. So it is the resolution is 2 by 2, right, which is the low resolution picture, right, and likewise indicate this as 4 pixels, and indicate this as 5 pixels, right. So the resolution is right? So high resolution, right? It's comparatively, right? Comparatively low and comparatively high, right? Yeah, copy it down, people. All right, one is done. How about others? Right, great. It seems everyone is done. All right. Let me know, is there anyone still doing this? Otherwise, we can move to the next part of the lesson. All right, we are moving to the other one. Right. So next we are going to talk about the colors, right? So this is something we should understand when we are working with a graphic editing software, because there are two ways that the computer is recognizing the colors. One way is they are recognizing colors as the RGB, red, green, blue colors. And the next way is the CMYK, cyan, magenta, yellow, and black, right? Now, there are these two schemes where we can maintain the colors in two different manners. Or like both the schemes are going to give you the same color, but the tone is a little bit different, right? But this is happening because of the graphic editing requirements, right? Like when you need to plot the colors on a paper, and it is going to be something different when you are plotting colors on a different kind of materials, right? So the red color that you can see on a paper will not be the same red color that you are going to see it on another material. So likewise, when we have different type of requirements, we have to choose whether we are going to go with the RGB colors or CMYK colors, right? So there are two types, as I told you, RGB and CMYK, and it represents the colors, the visible colors that we can see and that we can use, right? And as the note says, it says there are about 16 million recognizable colors visible to the naked eye. So this number comes from the mixture of colors. So as we talked, either the red, green, blue is going to create these colors, or CMYK, cyan, magenta, yellow, and black together is going to make these colors. So some graphic editors have RGB values to when we are creating a particular color, and some graphic editors are having CMYK. And there are some which contains the both, right? So RGB model, as it says, it is it consists the red, green, blue, and all the colors are like created out of these, the mixture of these red, green, blue. And I'll show you when it comes to the gym how these mixturing take place, right? And here's an important thing. This is widely used to create images on the television screen or computer screen using colored lights, right? Now, here in the CMYK, this model is used for printing on papers using colored inks. The primary colors used here is cyan, magenta, yellow, and black, right? So majorly, if you are seeing something on the screen, it comes to us as a RGB, but we are printing on a paper, it's going to be CMYK. So as I told you, RGB color is not identical with the CMYK color. Podi color tone එක change එකක් තියෙනවා. So as a graphic designer, you should have this idea for what purpose that I am making this graphic. If it is used to display on a particular screen, it's better you go with RGB colors. Then the colors that you can see will be the colors on the screen. And if it is going to print on a paper, then it's better you go with CMYK colors, right? So as you give the CMYK parameters and create a color, and that color will be the color which is going to print on a paper or a printing material, right? So it's better you have that idea. RGB is for the screens and all these things, and CMYK is for the printing purpose, right? Okay, here they have shown you how the colors are being mixed up. So some general stuff, right? And this tertiary color formatting, I'll tell you how it happens when it comes to the GIMP, right? I'll show you what is the place that the GIMP is used in this thing, right? So before that, let's write about this thing. So what are we going to write? Yeah, have the subheading called color, right? And it's better you start from here. Saran, it is because the printing machine is using the colors inside the printers according to the CMYK scheme. Yeah, CMYK values වලින් තමයි colors ටික mix කරගන්නේ. එතකොට දැන් RGB වල red එකයි CMYK වල red එකටයි slight parameter different එකක් තියෙන්න පුළුවන්. Right? එහෙම වුණාම තමයි අර අපි ස්ක්‍රීන් එකේ අපිට පේන්න තියෙන රතු පාට නෙවෙයි print කරාම එන්නේ. Right? ඔන්න ඒ වගේ different එකක් එන්නේ ඕක නිසා. Right? Okay, so have the heading color, and you can write this and show this diagram very quickly. Right? Color models, there are two types. Right? And please copy these things onto your book about the RGB and the CMYK. Minol, CMYK is like the purposes are different. Minol, CMYK is using for printing purpose. එතකොට අපි printing වලට දෙයක් design කරනවා නම් Minol, we have to do it. It's better we go with the CMYK color combination, not the RGB color combination, because RGB is the thing that we can see on the screen. Right? So අපි CMYK වලින් අපි red එකක් තෝරගත්තොත් that red is going to be print on the paper as it is. Right? RGB වලින් red එක තෝරලා print කරොත් print වෙන්නේ CMYK red එකකින්. Right? So there can be slightly different when the thing is being printed out. Now we can clearly recognize this in the ink tank printers, right? So once that is done, I will come.
I need a minion.
Fix it in your TV.
Right.
Let's go.
No, this TV. This TV.
Yes, people, are we done? Yes, Lamai, are we done?
Done, sir.
Yes.
All right. Is there anyone still writing this? Okay, so let's move forward. Yeah, what they have said here, do we need to write it down?
No, he's so bad. No, he
Right, now when it comes to the GIMP software, you will see this color palette, which will allow you to choose the colors for different kinds of purposes, right? When you are choosing a brush, you need to give a color to it, right? When you are choosing the paint bucket, you need to assign a color, right? So likewise, when you are typing something, you need to color to that particular font, right? So on those cases, we will be given the chance to select the particular color, right? Now, as you can see here, they use these RGB values, red, green, blue values to create a color, right? So when you are working with this, you should have the idea that this particular color that you can see on the screen is not going to be the color that we are going to, like it's not going to be the color which is on the printout, because this is given in RGB, right? If you could, if you have the facility to adjust these elements or adjust these parameters in CMYK mode, then you can have the assurance the things that I am seeing on the screen will be same when it is being printed, right? But in the GIMP, we don't have that facility. We have RGB colors, but it, again, at the end of the day, it won't make a very big difference, right? ඒ කියන්නේ අර අපි කියනවා ඉදුණු කෙසෙල් ගෙඩියක් print කරන්න දුන්නාම අමු කෙහෙල් ගෙඩියක් වගේ print වෙන්නේ නැහැ. It won't happen like that, right? But there will be a very slight difference, right? For a output which matters that different will be a problem, right? ඒ කියන්නේ අපිට හරියටම ඒ color tone එකේ මෙන්න අවශ්‍ය නම් print out එක then it's better we go with the CMYK color combination. CMYK color combination can be found in many other graphic editing softwares, right? So you will be able to match that particular thing, right? Okay, so here they have shown you how these parameters can be changed, and this particular number you can see here 143 is there, 28 is there, 25 is there. So these numbers will vary from 0 to 255, right? So if I illustrate this to you using GIMP, right? Now, if you want to take the color palette, you can click on one of these white squares, which we call the foreground color and the background color, right? We always work with the foreground color. Once we double click on it, you can see the color palette over here, right? So it is giving me RGB values over here. And as you can see, now R is 100, GE. Now here I have selected the red, so red is 100, no effect of green, no effect of blue. They are not being selected. Now if I click on somewhere here, right, you can see how the changing happens, right? Now this shows the shadings of the red. If you want to take the shadings of the green, I'm clicking on this G, then it gives me the shadings of the green, right? If I need to shadings of the blue, I can have the shadings of the blue, right? Or else I can just type the values over here, so I can make my own color. Now if I give 255 over here and 0 over here and 0 over here, right? So it will give you the color as red. So this is the current color that it indicates, current and old, it says. So this is the current color, it gives me red. And if I put 0 over here and 255 over here, it will give me the green color. This is the green that it gives for no 0 and for no yellows, no blues, right? If I put 0 over here and 255 over here, it will give me a blue color, right? මෙතන එන purple එක නෙවෙයි, මෙතන මේ පොඩි කොටුව ඇතුළේ තමයි හරි color එකක් පෙන්නන්නේ, right? So that is what we take in to indicate for red, green and blue individually. So combination of those, then I'm මෙතන green වැඩි කරොත්, I red වැඩි කරොත්, I'm going to take a different color, right? Blue අඩු කරොත්, see my colors are getting different, right? So likewise, we can change the color tone, right? And it will generate you different colors. And if I make this 0, this is 0 and this is 0, right? It will make me black color. It's gonna have any black, right? So no red, no green, no blue will give you black, right? And if I make this as 255 and this is as 255 and this is as 255 as well, it will make me the white color, right? So it's better you remember those things, right? So red, green, blue, there are values from 0 to 255. If red is 0, green is 0, and blue is 0, will give you black color. If red is 255, green is 255, and blue is 255, will give you the white color, right? Yes, everyone, is that clear? Soon we are going to come to this particular interface. For the moment, just give me the confirmation. Is it clear what happens with the RGB values?
Yes, sir.
Right, great. Okay, so let's mark this on the book, right? So here we go. Let's say it like this. Yeah. Yeah. It's better you don't need any particular subheading. Just continue the same heading, which we write it as color, right? As the next point, just write this down, right? This particular one. Yeah. Okay, one is done. How about others?
Answer.
Right, okay. So let's continue. So the next one is talking about the graphic size and the compression, right? Like when it comes to the graphic size, we talk about it like it's depend on the resolution, right? So, and the resolution will determine how many number of pixels are going to use inside that particular graphic, right? And then again, number of colors is also going to be a fact that we can have an idea about the size of the picture. Why? Because if your picture is less in colors, that means your pixel is using less amount of colors. So in other words, it says it is a particular pixel contains less amount of bits. Earlier we talked about if the number of bits inside a pixel is increased, that means it can represent more different colors. So if your picture is less in colors, that means pixel is containing less amount of bits. Less amount of bits means a reduction or making the particular picture low in size, right? So anyway, at the end of the day, the size of the picture will define by the bits. So we know in an image, bits are used inside a pixel, right? So if you are using the pixels with less amount of bits, it will give you a low capacity picture. If you are using a particular pixel with high amount of bits, it will give you a high capacity picture, right? And then the other factor is the compression, right? So compression that can be carried out in two different ways, right? So we can take it as lossy compression and we can take it as lossless compression, right? So anyway, compressing means we are like making the file size smaller, right? So when we need to do the compression, we can do the compression without harming the picture quality or with some particular damage to a picture quality, right? So the best way that you have to manage lamai mata vinadiyak denna lamai. Right, sorry for that, people. Okay, so when we are compressing the things, we can use two different methods to compress. We can compress it. Lama, just a second, just a second. Right. Sorry for that. Little one is a little bit disturbing today. Right. So we can use lossy compression or lossless compression, right? So the lossy compression, that is something that we can, where we can compress the picture, or like making the picture size smaller, uh, with some damage to the picture quality, right? So later when you are like uh, open the graphic, it will not open in the original form, right? Then when you are sending the pictures from WhatsApp kind of instance message services, they will compress the image, and some particular damages will happen. Then අපිට ගොඩක් වෙලාවට graphic editing කරන තැන්වලට අපේ details එවන්න කිව්වම they prefer having an email, or they prefer having the document upload into the Google Drive or something and allowing them to download, right? It is because of the this quality loss. If we like send it through the instance messaging and all these things, it's going to compress automatically. So it is a lossy compress, right? And we can do a lossless uh, compress as well, right? So for that, we need to have that properties inside that particular image. So then once the graphic is open, no harm has been done to the particular graphic, right? Later, we will talk about these graphic types as vector and raster, right? Where we will be given the chance to compress in a lossy manner as well as a lossless manner, right? So before we come to that, let's write about this particular thing, right? So regarding this, yeah, have the heading graphic size and compression. Yeah, then you can start it from here. And you can copy these things. Right, and it's better you add these things to that note as well. Yeah, people, you have to copy the entire paragraph because it's explains what is like how the lossless and the lossy compression is done. So please copy that out. Okay. And Diniti is asking, how can we represent CMYK by numbers? Yeah, do it's like this. Now, CMYK facility is going to be given to you, right? So you can represent CMYK colors in the way they have represent the RGB colors in the color palette. Otherwise, you can map the CMYK colors into RGB. Rather than order red එකක් ගන්න අවශ්‍ය නම් what you are going to do is like first you consider the CMYK red and you find the CMYK color you want. Then you find what is going to be the RGB color to output that CMYK color. එතකොට ඒකේ parameters ටික පොඩ්ඩක් එහෙට මෙහෙට කරලා RGB හරි color එක කියන්නේ CMYK color එකට match වෙන RGB parameters ටික දුවට හොයාගන්න පුළුවන්. Right? If you like surf in the internet, you can find what is the relationship between these two, right? So you can represent that.
Okay, sir.
Right? All right. Okay, so people, I'll go through this graphic types within a short 3 to 4 minutes, right? So we can end the session. So we can straight away start the GIP software from next week onwards, right? Right here in the graphic types, we are talking about 2 types of graphics, which is the vector graphic and the raster graphic, right? And it's better you have the idea what is vector and what is raster, right? Because it depends on the software that you are using when you are creating an image to be categorized it into the vector graphic or the raster graphic. And again, it is very much important for you to have the idea what kind of a graphic or like what type of a graphic that you need to output, right? Because there are certain situations where we need the vector graphics but not the raster graphic. But and again, there are some situations where we need the raster graphic, not the vector graphic, right? So you should have the idea about what is vector and what is raster, right? And to clarify this thing, you can use this particular table in here, right? So raster graphic, it says the array of pixels in different colors. That is in the raster graphic. Now you can remember that in the diagram that we discuss about the pixels, we have seen the array of pixels, right? Array එකක් කියලා කියන්නේ නේද? Pixel set එකක් එක ළඟ arrange වෙන විදිහ, right? And vector graphics by collection of straight or curved lines, right? Now this is different, right? Raster graphic made out of pixels, and vector, it is a collection of straight or curved lines, right? And raster graphics, it is not containing any records regarding the file. In vector graphic, they maintain a record of start and end of the lines and number of lines, straight and curved lines, how many are there and how many colors are being used, right? So in simple, if you want to create a high quality graphic, it's better you go for the vector graphic, right? Raster graphics are not for the high quality creations, right? High quality creations in the sense, like if you want to enlarge and compress without any loss of details, it's better you use the vector graphics, right? Not the raster graphics. And there are specific softwares that provide you that has been provided to create vector graphics and the raster graphics separately, right? And quality of the graphic, like when it is being compressed or like when size is changed, the quality will be changed in the raster graphic, but not in the vector graphic. Vector graphic maintain its quality even though the size is being changed. And as I told you, for high quality creations, raster graphic is not suitable and vector graphic is suitable, right? It is because it contains all the data. එතකොට එයා curve එකක් enlarge කරනකොට enlarge කරන්නේ pixel එකකින් නෙවෙයි. ඒගොල්ලෝ ගාව තියෙන record එකට අදාළව curve එකේ දිග ඇත්තටම වැඩි කරගන්නවා එයා proportionately, right? And creating and saving use less memory space, raster graphics, and vector graphic needs more memory space. And when the specifically when the speed of the computer is influenced or affected by the raster graphic creation, vector graphic creations, but not in the raster graphic creation. The raster graphic creations වලට local memory requirement එකක් එන්නේ නැහැ. But vector graphic creations, yes, you need that the memory capacity and the performance as well, right? And these are the softwares now. Adobe Image Ready, Photoshop, some famous name, right? Even the GIMP, right? That is belongs to the raster graphics, right? If you have heard about the Illustrator, right, and all these CorelDRAW products, those are belongs to the vector graphics, right? So here they have given you the difference of the vector and the rasters. So you can see this vector graphic has very sharp edges and it is very clear when it comes to the comes as a picture, right? So this little star, මෙතන තියෙන පුංචි star එක තමයි මේ enlarge කරලා තියෙන vector and raster වලින්, right? අපිට එහෙම එක පින්තූරයක් vector and raster දෙකෙන්ම enlarge කරන්න බෑ. So what they have done is like the same star is created from the vector and created from the raster. So if it is created from the raster, it is a collection of pixels. And when it is being enlarged, we know the pixel is being enlarged. So at some point, your picture is going to become a low quality one. But when it comes to the vector, it never happens, right? If you enlarge it, it can still be enlarged, right? So that is the difference between the vector and the raster. And people, as the homework, I want you to copy this table to your book. So have the heading saying graphic types, right? And please copy the entire table. You don't need to write anything on the paragraph, right? So copy the entire table as the note for the graphic types. So by next week, we are going to start the practicals, right? So I'm doing the practicals. You have to go through the notes, and probably we may need to copy this thing down, so which you are going to copy at home as the homework. And I'm doing the practicals for you, and I'll introduce the tools and all these things, right? Okay, people. So thank you very much for staying extra 10 minutes, right? So I'll meet you on next Sunday for the very same time, right? Thank you very much, everyone. Have a nice weekend.
Yes, sir. Goodbye, sir.
Right. Okay. Thank you. Thank you very much.
Thank you, sir.
Thank you, sir.
Right.
Thank you, sir.
Right. Okay, people.
Yes,
Thank
sir.
you.
Nice, very much.
Right. Okay. Right. Okay.
Thank you, sir.
Right. Okay. Right. Okay, Pradam.